Hello everybody. Hi, nice to meet you. I've just been told we can start. Obviously my name's Trish Woods and I'm here this afternoon to well, it's quite nice. I'm here this afternoon to talk about myself, which you don't get to do very often. I've spent most of my life talking about other people, so it's quite nice. What I was hoping to do was really give a little background to how I got involved in the craft and a bit about my career to date. And then obviously, which I think what most people are here for, is to go over some of the research that I've done into the coloration of pewter and why. And I often wonder that as well. But and then move on to some of the ideas that I've got now and how I'm hoping to take work forward. I have got a few little samples. Obviously, I've got a stall out there that you're more than welcome to browse through, but I've got a few little samples which are sort of like little punctuation marks of my last 12, what date is it today?
18th of May.
Probably 18th of May, yeah. And my last 15 years of experimentation. So the little punctuation marks give you an idea of how I've got to where I am today. So, where to start? Well, I originally trained as a silversmith. I went to Loughborough College of Art and Design, and I did their jewellery and silversmithing course, but I specialised in silversmithing. So even though I work in pewter now, I use those silversmithing techniques. I like working from flat sheet, and I bend and fold and raise and work as a silversmith, I suppose. I've never really been into jewellery, and even though I was on a jewellery and silversmithing course, I didn't really make any jewellery. So the jewellery I make today has really become a byproduct of the pewterware that I've started making. So you'll see a little bit of conglomeration. And the jewellery came from the patination work that I started many, many years ago. When I left university, I milled around in various places. I worked as a graphic designer. I did some evening class teaching. And then, it's nice, I hope that's going to Barbados or somewhere nice. Somehow I ended up in teaching, and I got a one-year fellowship at South Devon College in Torquay, teaching jewellery and silversmithing to their foundation students, and somehow I ended up there for 35 years. And met my husband down there and settled, and I started up a jewellery silversmithing crafts course. Whilst we were starting the course, it was a foundation degree, which is like a 2-year degree that you do the bits from. And whilst we were doing that, we were looking around for competitions for the students to get their teeth into, and I came across Pewter Live and knew absolutely nothing about pewter. But we thought, this looks nice, a really good competition, look at the prizes, that's really good money if you're a student. So that got them hooked, and we started doing the Pewter Live competitions. But what was lovely about doing it, and this is where my work has come from, is that because none of us knew anything about pewter, we started making rock bottom. We made every mistake possible. You know, you go to a book and it says you do it like this. Well, I've never done it like that. And this idea of a right way and a wrong way to work and whatever just didn't happen. We just hit the workshops and we played with the material. And we actually did some quite amazing stuff over the years, if I think about it. And many of those students won Pewter Live. We used to do it every year for quite a number of years. And they were really successful. And I learnt so much about the metal whilst I was doing that with the students. And in the middle of all that, because obviously teaching wasn't enough for me, I've got this brain that has to keep ferreting around trying to find stuff. So in the middle of all that, I decided to do a PhD. And so I was teaching full-time, did a PhD. And because I was fascinated with the pewter, that's what I was going to do my PhD in. All the work that I did before, I've jumped a bit. All the work that I did before was very much about the patination of metals. And so that history of my making comes through. I thought I'd just throw in a picture of my workshop, because people say, where do you work? Well, I had a lovely workshop in Devon when I gave up teaching. I set up a lovely workshop in the craft centre. I had everything there. It was great. My husband retired, and we looked at Devon, and he said, what are we going to do now we've retired? And I said, I've got a lovely workshop, but I don't want to retire in Devon. I called Devon Little Old Lady Land, and I wasn't quite ready for that. And we were looking to downsize, and all we could find was bungalows, and I wasn't ready for that either. So one day I said to my husband, who was brought up in Liverpool, how do you fancy moving to Liverpool? It's a lot livelier up there. And so, 2018, we moved to Liverpool. So I lost my workshop. And actually, I found out in the move, I lost pretty much everything. So this is my workshop now. That's it. Bench. So all my work is done at that bench. I don't have any heavy equipment. I don't cast, because I'm silversmith. I just work in thing. I've just got that. Hand tools. Slightly to the right, I've got a tiny little rolling mill, which is nothing like the one that I had in Devon, which I sold to an ex-student, and I moved up to Liverpool and go, why did I do that? Because we thought we were going to move into a little flat. Ended up with a 3-story house, so I could have bought all my stuff. And a guillotine, and that's it. So yeah, so that's where I work, which I think is a nice contest for you to actually see the place, to understand the stuff, yeah? Okay, so patination. All my work up to date, before I got involved in pewter, I was working with copper and silver, and I love what they call artificial patination, which is the chemical patination of metals and the colours that you can get, and therefore the contrast between that earthy patination and the crispness and the sheen of the metal, the new metals, whether it's silver, pewter or copper. So when I started my PhD, what I wanted to do was to get that colour that I was getting on copper onto pewter. And as you know, tin is an inert material, it doesn't tarnish. Most patination is based in the tarnish of metals, so it's a controlled tarnishing, if you like, and being able to stop that tarnish at certain points or accelerate it to get the colours. Romans were really good at it, and antiquity. But obviously tin doesn't tarnish, so where do you go from there? Stubborn as I am, well, you must be able to colour it, because when we accidentally melt it, you get a blue iridescence. And I'm sure all the pewterers in here know that when you get a certain heat on pewter, you get this rainbow effect, what we call the heat spectrum, yeah? Which you can control on other metals, but pewter it's like that because of the temperatures that you work in. So in my head, I'm thinking, well, if it does that, it's oxidized at some point. So if it oxidizes, then you can color it. So I started experimenting and researching and looking at really old pewter, because I knew that old pewter did oxidize. Most of it is because of the lead content, and there's no lead content today. But also some of it was because this pewter had been lost. It had been buried or sunk or in the sea and retrieved, and its surface had changed. And I actually went to the V&A and went into the archives and ensconced myself in the archives of the V&A and looked at all this stuff, and I looked at a few national collections, and I was always fascinated by this stuff. And you've got a couple of pieces upstairs. And there's this lovely golden iridescence. Well, it's not iridescent, but there's this golden quality. And that's called nature's gilding. And it comes from when pewter has been buried in iron-rich soil. So that was my first clue, iron, hence ferric oxide. Ferric oxide is iron. So I grabbed the ferric oxide out of the college cupboard and off I went. Nothing happened. Nothing happened at all. So my next stage, which I was talking to Paul about easier, was when I was home, I just got everything out the kitchen cupboards. And I just went for it. So I was throwing tomato juice on stuff because I knew the traditional colouring recipes weren't working on pewter. So all that oxidisation stuff that you use for copper and whatever doesn't work on pewter. And that's because of the tin. So I thought, well, okay, I'll be unorthodox as normal. So I emptied all the cupboards. I was mixing eggs up with tomato sauce. I was getting the colour that I use on my hair, because obviously I'm a bleacher. And getting all that, plaiting it around. I had bits of metals all over the kitchen, bits of metal all over everywhere, and it was covered. I was writing copious notes to remind myself if it was tomato juice or brown ketchup or whatever it was. And I was getting somewhere, and 2 or 3 of those pieces actually came up, and I discovered nature's gilding almost by accident. And I thought, brilliant. So, and the one that I discovered, this is nature's gilding here. So the one that I managed to get was close to that, and wrote it all down. I thought, I'm getting somewhere. So I spoke to, I think I was up here, and who did I speak to? I can't remember. But anyway, I spoke to someone saying what I was trying to do. So they say, you need to speak to the guys at the International Tin Research Institute. Actually, it was Kevin Kearney. You know, a lovely, lovely man, Kevin Kearney. And he gave me papers on Japanese techniques for colouring, which was basically lacquer work. So I contacted the International Tin Research Institute, and here I am. So as part of my PhD, it was quite nice, university gave me some money, and I used to go up to the International Tin Research Institute, go into their labs and chat to them. And they were actually quite fascinated. So in the time that I was working at the institute, I had a basic, I explained to them what I'd been doing with foodstuffs. We broke that down into various chemicals. We worked out what sort of chemicals were attacking the surface of old pewter to give sort of white crust and nature's gilding and things. And we started to play. And it took 2 years at the institute, and after we started to make a breakthrough. And we played around with all sorts of different chemicals, and the trick was to find the recipe, if you like. We had to think about how we knew that if I didn't completely degrease the surface and almost cut the surface, you know, scrape the surface, I wouldn't get any colour. So we abraded the surface, played around with the mixtures, and then one day, it was almost a eureka moment where I was playing with the same things at home and I got the bottles mixed up. And I did something and I got iridescence. And I went, oh, how did I do that? So I went to the bottle I thought I'd used and nothing happened. Then I realised I'd used the wrong bottle, which wasn't labelled properly, obviously. So I took it up to the Tin Institute, and they have all these spectrogram things and chemical testing machines. It's all like science in there, and I'm not a scientist, obviously. And we tested it out, and we broke down the chemical solution that I'd found, and we started working from that. And it was great. So we then had colour. Once I'd got that colour, I could then start to look at how I controlled it. So timing was the important thing. So I've got a liquid. I needed to know if I needed heat. It worked with heat. It works at 90 degrees. Now when you heat this particular solution, which I won't go into the details of it, but when you heat that particular solution to 90 degrees, you get gases. So we had to work in cupboards where, you know, whatever, all the gear. We looked like bumblebees. And by changing the timing, changing the slight concentration of the chemical solution, changing the temperature, I could actually start to control the colour. And that was brilliant, because if I can control the colour, I can stop it. So I can get a particular colour, and then if I can get a particular colour and I know what's happening, I can repeat it. So I got to the point where, as you see with these, I could get the blue. I could get the gold. The gold's the easiest one to get. And if I went too far, I could get the green. So the next 5 years, 7 years it took me, which is why I don't give it away like this. So the next 5 years was all about control. And I managed to control, and the Tin Institute were great. And when I was in their labs, they'd come running in. They'd say, "How you doing?" I said, "I've got this. How did you get that?" And they'd all be there like this, trying to work it and get their spectrum things and whatever, and it was great fun. And they really supported me, and they sent me to all their conferences, and I got to go to Hong Kong, and I got to go to, where else did I go? Cologne and various things, talking to the industry, showing the research, showing the colours, showing the samples. Really supportive. But obviously all those people were from the tin suppliers. And one little Chinese man came up to me once and said, "What's your tonnage?" And I just about 8 stone. So yeah, so that was fun. So yeah, so we cracked it, and at that point, well, almost alongside it, I started to look at the surface, because you learn very early on with the type of colour that I was getting, which was like an iridescence, even though I could stop it at green or blue, with the iridescence, if I could alter the surface and have a multifaceted surface, the light's going to catch it. And if the light catches, you get a much more interesting visual optical effect. So I started playing around with pattern. And what I did is, I've got some samples here, you can have a look at these early samples. What I did is I used magnifying photography to look at the structure of the metal. So I took photographs of the structure of rolled sheet, rolled pewter, and cast pewter. And you get lovely patterns. So I then took those patterns, played with them on the computer, and developed patterns myself. So this geometric one, yeah, this is actually from the structure of rolled sheet. Yes, that's what rolled sheet sort of looks like if you look at it under a massive magnifying glass. So I really wanted the patterns to actually be part of the metal. That was important to me, to maintain integrity. And when you come and have a look at these later, these are cast. They're not cast, they're sheet metal, but the patterns come from the structure of cast pewter. So it's a very different structure. So I started to play with that, and then obviously from that, it was a matter of then applying what I'd got to work. These are actually some of these. So the control was getting more there, the surfaces were coming, the iridescence was starting to come, and now I can make, because that was the primary thing. And my PhD has got a very long title. It's called An Investigation into the Potential, what is it? I can't even remember it. An investigation into potential chemical patinations and applications. So application was a really important part of the PhD. So I made a whole body of work, and that really kick-started the rest of my work. And it's the reason why I gave up teaching, because I finally had something of my own that I didn't have to give away to students. Yeah. So initially, this is the first body of work that I did from that. So you can see the blue and the iridescence. I still make the bangles today, but they're different, because obviously, all those years later, my work's evolved. But also, I'll come on to it in a minute. I don't do the chemical stuff anymore. So you can see the patterns. You can see the iridescence, and then I applied them to products that I could make easily. And I was learning how the material was working at the same time. So these are bangles and pins and serviette rings. And I also started to push the jewellery side. But most of my jewellery is quite sculptural, and I think that's because I'm not really a jeweler. I tend to see myself as a frustrated sculptor that did a crafts course. And I had a friend, one of my colleagues, who was a really good jeweler, but he was a sculptor. So we somehow got mixed up along the way. It was really strange. So I started to make, this is obviously a neck piece, and it's made up of lots of links, and the shape of those links came from some of the patterns that I was developing as well. So it was a whole integrated approach between the colour, the surface and the form, which I think is quite important to me in some respects. My work started to get a little bit larger, and I started to produce these bowls, and the pattern is on the outside, and then because they were larger, the chemical solution that I developed was working in a slightly different way, because where I was working, and if I was making something this diameter, I've got to heat that chemical up to 90 degrees Celsius. So it was really difficult to think about how to do things, yeah? Because I didn't have a laboratory workshop, I just had a small craft workshop. So the colours changed a bit. But I was still managing to get that iridescence and that play. And the green became more and more prominent. And I think the reason why the green became more prominent is because if you let the solution, the heat, as you heat it up, the first colour you get is gold, then it goes pink, then it goes purple, then it goes blue, then it goes very pale blue, and then it went kingfisher green, and then dark green. So I was finding, when I was working on the pieces after I'd left teaching, was working in the craft shop, to control the larger pieces, it was harder to control the heat or control the way that the what they call it, the stages were going, yeah. So the green was becoming more and more prominent, but I actually quite like the green. And if you look at my work, you see I use green quite a lot. I then also started, because I wanted then to make work that was interactive. I didn't want to make just sculptural or pieces that you hung on the wall or stuck on the side of the table. I wanted people to interact with them. I've got a bit of that William, although I don't relate myself to William Morris at all. I don't actually like William Morris work. I'm a Christopher Dresser fan, if you know who he is. He's amazing. But I do believe in that idea of function, object, yeah, that sort of thing. You can have a beautiful object, it can be very sculptural, and I like the idea of a little applied or sort of application, you know, function. And so I started making, I went back to the history of pewter, and one of the most common and oldest, apart from a tankard object, is a salt. And when I looked, the time I was doing that, there were hardly any salts around. So I thought, well, why is nobody making salts? And it's because, and this is what I hate about the 20th and 21st century, you know, you have rotten plastic things and go like this, or like this. And the salt goes all claggy in there, and you have to stick stupid bits of rice in to absorb it. And I thought, well, why are we doing that? Because originally you put the salt in a bowl and you took a pinch and you worked with it, and then, you know, it's fine. And if it's humid, you put it back in a tin or whatever. So I started making salts again. Well, not again, I started making salts. So I developed this idea of bringing the colour with the contrast of the metal, because I love the sheen of pewter. You notice a lot of my work isn't highly polished, it's a soft sheen, and bringing the colour into it. I also had to check with the colour that it's non-toxic. So I had to protect all sorts of things, protect the surfaces and things. So A, it's non-toxic, and B, it doesn't erode with foodstuffs. And I produced the little set of salts, which I was very chuffed, won the Neish prize. I can't remember when. How long ago was that? I don't know. But anyway, so I won the Neish prize, and that really stirred me on. So yeah, and I still make the salts today. Anyway, I moved to Liverpool. Yeah, I moved to Liverpool, and then that was a big shock. Not Liverpool, but moving to that workshop, yeah, because I had nothing. I had my hand tools. That was it. I sold it all. So I was working. This was a patinated vessel with the green and the ochre and the nature's gilding. So I went back to I call them colours of dawn in dusk and nature's colours. So this was one of the patinated ones. And when I moved to Liverpool, I'm thinking, I can't do that anymore. I haven't got a facility to work with the chemicals. Also, I'd been doing it. My PhD was finished in 2011. So that's a while away. And I'd been working with those chemicals for a while, and I thought, if I keep doing this, I'm not going to have a brain left, because these chemicals are whatever. So I thought, well, the chemical stuff has got to go, but I want the colour. So my next stage of work was very much about trying to find new ways of getting that colour, but in a non-toxic, and it's good, isn't it? Must be the bin men. They've come to take me away, I think. But yeah, to get those colours, get those surfaces, get those patterns, get that contrast, get that visual strength and quality, but without the toxicity of the chemicals or the dirt of the chemicals and various other things. So I started to think, well, what do I do now? So I went back to the cupboard, and it's amazing what you find in cupboards. And only this was an artist's cupboard, not a kitchen cupboard. Went back to the cupboard and started to find things that I could use. I know I had to start applying the colour onto the surface, not develop the colour onto the surface, because the chemical develops. I can't do that anymore. So I had to think of ways of applying. And yeah, so I started working with all sorts of things. I didn't want the work to look painted, because then you lose the pewter. I still wanted the colour to have a semblance of the iridescence of the pewter underneath it, if that makes sense. Yeah? I've seen pewter work with the colour where they just paint it, and it looks dead. So I needed to try and keep it alive, and that iridescence still I was going with that. So my new work is very much about applying a whole range of different things onto the surface of the metal that I can then integrate with lacquers and foils and various other things to get the iridescence and to seal the colour into the surface, because these have got to be used and people are going to wash them. So it was important that it's not going to just erode that quickly. So there's a whole range of different things that I use in current work. And what I've started to do is to use the surface of the metal as a canvas, so that I can manipulate the colour around and produce an overall sense of composition, if you like, within the work, if that makes any sense. And it might make some sense because I paint as well. I'm always, quite an avid drawer and painter. So it's about composing the surface, not just applying the surface. And what that does, I think, is it makes each object unique, and it also allows me to think about different approaches to what I do with the surface. So each object moves in a different way. So you'll see that this is another thing that's happening. I've got 3 or 4 strands on the way at the moment. So I've got these little things. This is, which are quite painterly. And then I've got the mixed media pieces, which is still quite painterly, but have a different quality, and then I've got this happening. And I think I've reached a point where I need to consolidate everything, so I'm currently thinking about where I go from now. So now I've got a workshop which restricts what I can actually make to some extent. I've got a whole range of techniques that I can use to think about the surface of things, and I've got lots of different types of work happening. The other strand to my work, this is where I've got to, if you like, with the surface stuff. You know, you've probably seen the piece upstairs, just showing you the little thing there. But I also, I'll go back to that one. I also love acrylic. So I've produced works in acrylic, because that gives you that flash of colour. On the left was a piece I did for Pewter Live last year. It's a cocktail shaker. And I've used the acrylic in there. And the iridescence to the surface has just come from a mixture of surface texture techniques. So I like to play with the surface, so it's not just plain. Jewellery, again, very sculptural. I'm often, I love architecture, so I'm quite often influenced by architectural form. Sometimes I'm just influenced by something I've picked up off the ground, yeah, and I see something and take it that. And then this piece on the right, which uses that acrylic again, was a ceremonial mace I made for South Devon College when I retired, and I'd finished with teaching, so they pulled me back to produce the mace. So I've got this very modern, clean work with the acrylic. I've got the painterly stuff, and I've got the patination, which I still want to get involved in. So my idea, this is where I am now, so it's almost like watch this space, is to bring all that together. So that I have surfaces that are part patination, part painterly, integrated with this very modern use of colour in acrylic, and I have no idea what I'm going to be making in the next 6 months, but no doubt it will turn up at Pewter Live next year. I just wanted to go back to this other slide, because this is really about the patination that I'm really, really interested in, this historical thing. This is a piece I made a few years ago for an exhibition. It's called Symbols of Alchemy. It was a very large necklace. And there are many stories of, I think it's 17th century pewter. Well, it's all been lost, but there was a 17th century pewtersmith that was renowned for mimicking gold. Yeah? So he was a pewtersmith who used, well, obviously it's come from nature's gilding somewhere. He knew about that, and he was playing with it to mimic gold, because pewter was the poor man's material, gold and silver were the rich man's material. So Pewterers in the 17th century were always trying to pretend that it was silver or gold or whatever, and he managed to, he did something. Unfortunately, none of that work exists. The name doesn't know, it's still in a bit of folklore. But for me, in a romantic way, what it does, it sort of conjures all that idea as the Pewterers, the original alchemists. They made their own alloys. They were trying to mimic other surfaces. And I really believe alchemy came from Pewterers. I'd like to think that they were the magicians there trying to make gold out of lead, because old pewter was full of lead, and the lead from the gold. I'd love to think that. I haven't seen anything official, but it's lovely. So I made this piece, which is called Symbols of Alchemy, and I imitated nature's gilding to mimic the 17th century Pewtersmith that tried to make gold. And I've also added gold leaf to it to give it a bit more of a luster. And the shapes and patterns, the symbols that it's made from, are the alchemical symbols for copper, tin, and antimony. And even the stones pick up on the folklore of meaning and alchemy in jewellery. So for me, that's my pinnacle of where my patination and the romance of why I patinate manifests itself. So as I say, I've no idea where I'm going now. I've got a vague idea, and watch this space. So I don't know. Any questions? I've got some samples here. These are some of the original controlled samples from chemical patination that I was doing for my PhD. And you can see some of the original patination on some of the bangles that I still make, which I've integrated. And this piece here is some of the original, and then obviously some of the stuff. And I have started to integrate this piece, to integrate, the painterly and the perspex. And I've suddenly become very oriental. So I've no idea what forms I'm going to get. So you're more than welcome to come and have a touch and a feel.
A long while since I read it, I've seen the Neish's British Museum publication on patination of metals, and I wondered if that talks about tin or pewter at all.
A lot of them don't. There's a renowned book that was published in I think it was 1980s by Richard Dixon or Richard Hughes and Michael Rowe. They were lecturers at Camberwell, and they produced the definitive book on patination. Pewter isn't in it.
I think Sula Neish, British Museum Research.
Yeah, there might be something there. I know I read.
Much more recent.
Yeah, I read Pliny, and Pliny talks about tin and tin alloys. I don't think he uses the word pewter, but that's what it is. Yeah, it is very difficult. But I did take a couple of chemical thoughts from Pliny and started to apply it. But a lot of the patination processes for pewter are about making it grey. I didn't want grey, I wanted bright blue and pink and yellow, so, yeah. But there's not an awful lot.
I was talking to you earlier about working with titanium and talking about disclosing the cell structure of titanium and then getting colours, because you can colour it by heat. I was talking about that. When you're talking about getting your colours and the iridescence on your pewter, were you talking about, to begin with, getting the surface texture or tooth on your pewter? Were you looking at sort of doing that by some sort of mechanical means, by scratching, scraping the surface, texturing it? Or did you actually try any sort of chemical means to alter the surface of your pewter before you actually tried some of these colouring techniques?
Yeah, well, the first thing I did was did the colouring. And then I started to roller print textures and etch. Those were the two things I did, roller printing and etching, and applied it to that. And that's where the colour was coming from. If you milled it, that lovely mill engraving, you'd get the same effects, because basically it's anything that allows you to alter the surface, so you get variety of surface depths. Change the depth along the way, and where something is higher up you get more light, so you get brighter colour. Where something's lower down you get less light bouncing off, so it becomes a darker colour. It's still the colours, but the light refracts through it and picks up light refraction, if you like, and that's where the iridescence comes from.
Refraction. So I often think about when working with silver, and when you're sort of going to anneal it, I always think of it as rearranging its molecules.
Yeah, well, you do, because they expand and contract. Yeah. When you heat metal, it expands. So what the molecules do is they stretch.
So you're changing the shape
Yeah, and when it cools down, they shrivel back up together and they knit back. So that's why, because they stretch and expand, that's why you've annealed it, because there's gaps and you can bend it. The minute those gaps shrink, that's it.
So using those photo micrograms, the big photographs, you can see that actual
Yeah.
cell structure in
Yeah.
the surface of either rolled metal or cast metal.
Yeah, you could see it. Yeah, and the difference between rolled and cast is fascinating, because when you think about it, when a piece of sheet is manufactured, it's come from a cast block, and then it's rolled. So, but the molecular structure, when you look at it in that detail, changes completely. It's quite fascinating when you start looking at stuff like that.
Would you be able to reproduce that?
Which?
Like that?
That?
Yes, again and again, or could you never reproduce that?
I can reproduce it, but the pattern I wouldn't, because I tend to be quite spontaneous in the way I apply surfaces. That's why I say it's the painterly quality. So I tend to be quite spontaneous and work on the surface at the time, and that's why each one is going to be different. I could get close, but it wouldn't be the same, because it's done in the moment.
Yeah.
Or rather the 2 hours that I work on it, yeah.
What is the time lag between when you start off with the first colours, you have the blues if you like, and how long is the process before it goes through the red, the
What, with the
purple, until it
chemical
comes through the
patination?
end?
About
Yes.
10 seconds.
Oh my goodness.
And it depends on the temperature as well. I did manage to get it down, I did manage to extend it to about 20 seconds, which is good, because it meant that I had time. 20 seconds, quite a long time. You sit there and count it, you know. So I had then time to pull out, but you've got to pull out right at that moment, and then you throw it in cold water to stop the heat. Because even though it's a chemical reaction, without the heat it won't work. Yeah?
So to do this one here.
Which one? That one?
Yeah, you've got
No,
three
that's
colours
applied,
there.
that's not chemical.
Okay, that's okay. I guess I've got it. Okay. So
These are chemical,
yes. Okay.
but they're multi.
You're right.
These, where is it? That one's chemical. But even then, because it's in the liquid, yeah, unless you're in a laboratory really controlling that heat. You see, if you've got an electrode, then that heat is that heat all over. Yeah, so if you plug it into electrics and get it, which you can actually. There was a member of the company. Oh gosh, what's his name? That's the guy. And in fact, you used to have a little iridescent green bowl. And he was using, I looked into his work and I spoke to him. He was using electrolysis. And you can actually control electrolysis to get the colour. It's the same, you know, a bit like electrolysis of titanium, yeah. And you pull it in phosphoric acid, yeah. And then you put the electric current through it, and then you can slightly increase the colour and you change, but you can get this green again. That iridescent looks like a green beetle colour. Well, of course, because of the electric, the amps or the current that you're getting, you can control the current, so you can control the colour much better. When you just got it in liquid under heat, yeah, it's hotter at the top of the vessel than it is at the bottom of the vessel. You know what I mean? So the heat changes. So you always get a slight mottling. And that's why I find these really exciting. So these have got a slight mottling because they went in like that. Yeah? Not like that. They went like that. So you got that slight mottling where it was slightly warmer at the bottom than the top. But also they'd been etched, so you got the light refraction working in it. I did try electrolytic heating. Coca-Cola's good. In fact, it's easier to get because Coca-Cola contains phosphorus acid. So it does all sorts, Coca-Cola. I don't drink it. Certainly don't drink it. unless it's got a very large Bacardi in it. But yeah, so yeah, there are some little samples of things happening. But the sad thing is, like, poor Tom Neal and things, it never goes any further because it takes years to control. I mean, the university patented my process because industry got quite excited that they thought they had a colouring technique that could work. But the problem with my process is it still has variable results, and industry wants exact results. I went over to Kuala Lumpur and did some work with them, and we got some quite interesting ones, and we got the green. That was when the patent was going through, but then it fell apart. And the most interesting thing, which I always found quite fascinating, like obviously you mix these chemicals with water, yeah, and there's a ratio that you work with it. And when I went over to Kuala Lumpur, they prepared the solution for when I got there, because I was sort of demoing it, and we did, and absolutely nothing happened. And I said, well, I don't understand that. They said, sure, we measured it, look and whatever, and they brought a tub of distilled water out. It don't work with distilled water, we learnt that one. I said, no, go and pour it out the tap. So they went and poured it out the tap, and we did it, and the colours worked. Don't ask me why, there's something in tap water. Even the Tin Institute couldn't work that one out, but it does not work with distilled water. And you'd think when you're dealing with chemicals that the purer your approach is, the better it is. But no, with my stuff, it must be something to do with me. The dirtier it is, the better it is. Yeah. Very strange. Yep. Okay. Well, like I say, you're free to have a little look at those, and then, yes.
Just that was absolutely fascinating. You brought in to us pewter, physics, chemistry, and great artistry, and even though I had to dip in and out, I'd like to blame the assistant clerk for not organising the rubbish at the right time.
No, that was fine.
So that was just absolutely fascinating.
You're welcome.
Thank you so much.
You're welcome. Thank you. You're welcome.